This is your soil and agriculture unit. This is the video 1 of this unit, and we're focusing on soil for this unit. So the definition for soil is that it's a surface layer, has to be in the Earth's crust. It's the surface of the Earth's crust. So it's a really, really thin layer, relatively speaking, and it's all of the matter that's affected by any erosionable force, so weather, wind, water, and organisms, anything that's going to move it around. So the depth will depend on the type of soil that you find. And the composition of soil, 4 different parts. Mineral particles is about 45%, organic matter is about 5%, water is 25%, and air is 25%. So 4 different parts. Most of them, 3 of the 4, are abiotic. The importance of soil, when you're looking at from a resource standpoint, you're looking at the microorganisms that live inside it, the bacteria that break down nutrients that the plants need. They depend on that soil for shelter, especially for food and water. That's where they get all of their nutrients and stuff. Plants use it to anchor themselves, stay put. They also use it for nutrients and for a water source. But that's not as necessary as the anchor. So it's the big thing to keep plants where they need to be, to anchor them and provide habitat. I disagree with that. Terrestrial plants can't survive without soil. They can't survive without the stuff in soil, but aquaponics has shown that they can survive without the soil itself. They just have to have the materials, the water, and the nutrients supplied to them. So we'll talk about that a little bit later. Okay, it's a very slowly renewed resource. It is definitely possible to overuse soil, to overwork an area, and we'll talk about that when we get to agriculture in the next notes. But the reason that it's slowly renewed is the presence of the nutrients inside it. So as soon as those are renewed, then it can be used again and again. The nutrients are used obviously for plant growth. The soil also helps to purify water. It blocks, kind of serves like a natural sieve and net, collects chemicals and other matter that would impact the organisms in the water. Okay, so weathering is the process where that matter is broken down. So it begins to make soil. You have to break down bedrock. It's a chemical process, a biological process, and a physical process. You have all 3 things working together that break down large chunks of rock into smaller chunks of rock, into smaller and smaller until you hit the soil size. And all of those together are called weathering. Mature soils have developed over a long period of time, and they are arranged in horizontal layers, and those layers are called soil horizons. So that provides scientists with a really good time frame to look at what happened and when from a geologic time scale, is to look at those mature soils. Okay, so the parent material, when we talk about soil formation, is the rock that we start out with before it turns into soil. So you have to break that down, like I said, from a large rock into smaller and smaller particles based on the weathering process, the biological breakdown from animals, the chemical breakdown as stuff is rearranged, subjected to different situations, and then the physical weathering from wind and water, waves, stuff like that. So it has to be 2.5 centimeters small in order to be counted, which is still pretty big when you think about it, to be counted soil, and that can take up to 1,000 years. So it's really a long-term process. So the physical weathering, an example of that is that's where the erosion takes place. The wind and the water can get in and break it down. Ice especially gets into cracks and stuff and creates bigger and larger cracks until you break off pieces of rock. Chemical weathering is looking at stuff, cell respiration, the CO2 production diffused into the soil reacts with water to make carbonic acid, this H2CO3. And so that carbonic acid will eat away parts of the rock and break it down into smaller pieces. So that's the chemical weathering. And the renewable or not, again, it's a very slow renewable process. The biological weathering comes from decomposition, which produces new soil. But the renewable term is debatable because in a lot of places, for example, tropical rainforests, the nutrients are caught in other places, in the trees or in the atmosphere, and then when that is used up, when the trees are cut down and burned, the soil can't get those nutrients back. So unless the nutrients are purposely put back into the soil, we can't renew that soil. We can't count it as a renewable resource. Okay, so soil properties, one of them is texture. Exactly what it sounds like. The percentages, we're looking at the weight or the mass of the different size particles, and we're looking, the three options are sand, silt, and clay that it contains. So the texture is how much sand, how much silt, and how much clay. Is it really grainy with a lot of sand in it, or is it really, really fine with a lot of silt or clay in it? Greater than 2 millimeters in diameter is gravel or stones. It's not considered soil because it doesn't have a direct value to plants, so it's not true soil. Plants can't put down roots within the gravel stone bed. 0.05 to 2 millimeters is sand. That's the largest soil particles. You can see those if you go down to the beach. You can see the different particles with naked eye. You don't have to use a microscope. 0.002 to 0.05 is silt, barely visible to the eye. It's the size of like a piece of flour. And then less than 0.002 millimeters is the clay. That's the greatest surface value, and that's only seen under a microscope. So the test really is to take it between your fingers and rub it together. If it feels really gritty, that has a lot of sand in it. If it's really sticky, and you can kind of clump it together in the palm of your hand, that's a high clay content. And if it's really smooth or runny, that's silt. The structure of soil is how soil is organized and clumped together. The friability, again, these are all characteristics of soil. The friability is how easily it can be crumbled. The porosity is how much water can move through it, or other materials can move through it. The volume and the average distance between the spaces. So the higher the porosity, the more distance between the spaces. Permeability is the rate at which water and air moves from upper to lower soil. So it's also the distances between spaces, but we're looking more at the rate for permeability and the distance for porosity. So that's the difference between those two. Continuing on with the properties, the size of the particles, the amount of space, and then how rapidly water flows through them is all properties of the soil. Looking at that diagram a little bit closer, make sure you're looking at the different surface area for the two particles, how that will affect the water movement, and how that changes the permeability of that soil. Okay, so the shrink and swell potential is this concept where, especially like clay, will swell when the water gets into it, and then as the water drains out or evaporates out, it dries and cracks. You see this a lot in Texas, where we have very clay-like soil in the summertime, where you have all those cracks in the ground. Really, really bad for house foundations. You know, you talk down here about watering your foundation and stuff to remove that cracking. The pH is a relatively high range, 4 to 8. So you're wanting really a fairly neutral pH, but you can get very acidic soil in the pygmy forest, and very basic soil in Death Valley. So there's definitely the exception that proves the rule, and that's going to determine the type of plant life that you find in there. So different pHs will, different plants will grow in different pH soil. They like different pH better. The slope of soil is, you know, are you looking at a valley, a field? Are you looking at something flat? Are you looking at the side of a hill or a mountain? So the higher the slope of an area, the less soil you tend to have on it, because gravity will wash that down, especially with a rainfall. Runoff tends to erode, like I just said, runoff tends to erode it as well. Moderate and low slopes encourage a lot of deep soils, because you have all that runoff dropping that soil into that area, into that valley, so you have a much more deep soil at the bottom of that. The depths of soil depends on where you are. Some is really shallow. Some can have, you know, 2 or 3 feet of soil, if not more. So it just depends on what nutrient levels you have, what erosionable forces you have, stuff like that, to look at the depth of water or soil. Sorry. The color of the soil, the darker it is, the more organic matter it has in it. The lighter it is, the less organic matter it has in it. So you're thinking about the stuff, like the really dark stuff you use when you're planting a garden versus like sand and stuff at the beach doesn't have very much organic matter in it. Okay, so looking at soil horizons, this is those layers. You can see up close those layers. The O horizon is the organic layer. That's the uppermost layer. Has a lot of organic material in it, all the plant stuff, all the dead, decaying stuff, all the bacteria. Plant litter accumulates in that and decays and breaks down. Places like the desert, where there isn't a lot of plant life, that O horizon is almost entirely gone because there isn't any organic matter to break down and decay over time. So it kind of depends on where you are as to how thick this organic matter is. Somewhere like the tropical rainforest, there's a lot of decay and a lot of breakdown, so you have a very thick O layer, O horizon. The topsoil is the A horizon. So you see it's dark and rich, has a lot of accumulated organic matter and a lot of humus, granular texture, and very nutrient poor because all those nutrients have leached out into the deeper layers or are being used by the plants at the top. The subsoil, or the B horizon, is light colored. That's a lot of clay. You end up having at times a lot of nutrients because they've pulled out, leached out of the topsoil and accumulated in this B horizon. Very rich in iron and aluminum compounds, very clay rich as well. The C horizon is all the weathered stuff that has the pieces of rock and parent material that haven't broken down yet. Roots don't really go this deep. It often has a lot of groundwater in it. This is that bottom thing. This is where everything kind of pools and ends up before it hits the bedrock layer. Okay, so looking at, again, take this and pause the video here, look through at the different layers, find each of them so you see the bedrock at the bottom. You see all the different layers here, how relatively thin they are. Make sure you take the time and look at each different option. Okay, so layers of mature soils. The infiltration is the downward movement of water through the soil. The leaching dissolves minerals. So the type of soil that you see will determine what types of minerals and what types of water are there, which means that they depend indirectly on the infiltration and leaching factor. Okay, so again, pause this, take a look through it, and look at the different types of soil that you're seeing, where you see it. Notice the desert soil with a hot, dry climate. Lots of clay, not a lot of minerals, very, very little, if nothing, from the organic O horizon. Grassland is different. Flip through to the tropical rainforest, you see the much thicker O horizon. So look through, pause and look through and compare all these, please, in all of these pictures. The deciduous rainforest versus the tropical rainforest with the still a lot of rainfall but different climates. How does that affect what the layers are looking like? Coniferous forest in the cold climate, again, how does that change it? You see a lot more of the acid litter layer up here. And then we are done.